We had a ventilation problem at one of the coal mines I worked at probably about, I'm thinking 18 years ago. A good friend of mine named Tim. He was working in an upper unit section of the mine. I was working in a lower section of the mine. I was one of the EMTs at the mine site. They couldn't find Tim. Two of the guys from the crew up above came down and got me in the lower section. We came up the upper section. We went down the entry that they last saw Tim in. We got to within about 30 feet of his feet. We could see that he was laying face down in the mine floor in the mud. At that point, the gentleman that was with me, Darlene, he started saying he starting to get a headache. He didn't really feel real well, queasy, blurriness of vision. I realized at that point we were at a low oxygen situation. We were the lucky ones. We got out. Tim didn't. We got to keep an eye on the ventilation. I mean, that's what saves lives. That's what allows everybody to go home every night. The purpose of ventilating a mine is to move fresh air from a point of high pressure to low pressure. Also, the movement of fresh air dilutes or render harmless any noxious or harmful gases that we have in the mine atmosphere. It also removes any respirable dust that may be floating around in the mine atmosphere. There's basically two ways to ventilate a mine. We have exhausting ventilation and blowing ventilation. Exhausting ventilation is we're pulling the air out through the mine through the return. Blowing ventilation is we're pushing air into the intake and pushing the air through the mine. The purpose of ventilation controls in the mine is to direct the airflow through the mine to the areas that we want it, in the volume that we want it. Examples of ventilation controls inside the mine are bradish walls, line canvas, regulators, back checks, and run-through checks. A line wall is a cinder block wall that we build that separates the intake air on what we call our primary escapeway from the air on our secondary escapeway to give us two distinct airflows to allow the men to come out of the mine safely. Problems that we see with the line wall is holes or cracks in the line wall that are not meant to be there. Allows air to move from one intake to another intake and allows the air to cross mingle. If there would be any contaminants, of course, they would move from one side to the other. The purpose of a check curtain is to direct the air to where we need it to be in the mine. It can either be a permanent or a temporary support. Temporary being where we're going to put a wall up. Before we put a bradish wall up, we put a check curtain up to direct the air. Problems with a check curtain is 99% of the time is they are not installed properly. They're loose, letting air pass through them, or they fall down and no one puts them back up into place. A line bradish is just like a check curtain. It directs the air, except for it splits the heading longitudinally, so we can direct the air to a specific spot, like the face in a mine. The problems with a line bradish are, most of the time what we find is they're not brought out into the main airstream current enough to move enough volume of air to the face of the mine. It is against regulations to leave a man door open because that does affect the whole ventilation of the mine. If the ventilation control is not working properly in the mine, it won't direct enough volume of air up to the face. A miner working inside the mine, to keep the vent controls working at 100%, the biggest thing he can do is keep his eyes open. Look around, notice things, and see things. If you see a door open, it may be open for a reason, but ask if you're not sure. But if you go through a door or a check curtain or anything like that, if you have to move it, open it, you shut it. If you tear it down, put it back up. The ventilation controls are designed and maintained in a certain way to supply a constant volume of air to where it's needed. If you don't know, ask. A lot of the guys work 5, 6, 7 years in the mines. They can ventilate up the face just fine. They do not know what goes on out by. We need to learn that. Some of the problems with ventilation that I've seen in my time, my career underground, are doors being left open, holes being left in the wall, not patched, the wood blocking on top of the walls not plastered, which is a fire hazard, also lets ventilation short circuit. canvas is not being hung properly or not being hung at all. We've got to make sure it's right. One thing through my career that was with the roof in the mine, a good friend of mine, he was a right side bolter in the section. Me and the face boss were over by the tail. He came over and told us he found some bad roof. He was going to go back, put 6-foot bolts in, back up 8 feet. Standard procedure, doing everything perfect. One of the guys from the crew came up and said they couldn't find the bolter. So me and the face boss jumped through the man door, went up the entry. When we came up to the entry where the bolter was at, we followed the cable to a rock fall. It's where it's very, very important to keep your eyes and ears, because there's only one person that can keep you safe in a coal mine, and that's you. On hindsight, and this is only a possibility, that if he would have been able to talk to his cross shift, the people that were bolting before him, maybe they would have said or passed along the information that bad roof was there, and he would have known that he was in a bigger area of bad roof than what he suspected, and we could have took other measures. Roof bolters have one of the most important jobs in the mine. They support the roof. They're supporting the rock, the strata that's over top of each and every person that enters that mine's head. Once they put that bolt in, once they drill that hole, put the bolt in and install it, once it's installed, they're the only ones that know if there was a problem there. There's no way to go back and check. It has to be done right the first time, every time.
The purpose of a roof bolt is to hold the roof up. It's as simple as that. The most common type of roof bolts used in a mine are fully grouted resin bolts. We have tension bolts, and we also have cable bolts. This is a number 5 rebar. It's a fully grouted bolt. It's also one of the most misused bolts in the industry, and I'll tell you why. The resin holds the roof bolt into the roof, but it's come a long ways through the years. It used to be a 2-minute setup time at best. Now you're down to a 10-second setup time. And that's created some problems on training. The people that used to have the 2-minute resin, now they were training everybody on how to do it with 2-minute. It was good at that day, but it's not good now. So we have to work in the industry to stop that and get them trained right. This is a good installation of a rebar roof bolt. You can see that it's been mixed right from top to bottom. You can see where the rebar is holding real good with the resin. This is an improper installation of a rebar bolt. As you can see, it spun good in the beginning, but as they went up, you can see it just gets worse and worse as you go. The reasoning for that happening is the men were taught years ago, when they only had 2-minute resin, that they could spin on the way up, and it was the right way to do it. But now with the resin being 10-second resin, you can't spin on the way up. You have to take it up almost against the roof. Then you spin at your spin time. Stop, and then push it tight and hold it your hold time. Simple as that. This is a resin-assisted tension bolt. It's mainly used to hold laminations in the coal mine. This has been made for tension to hold laminations together. The newest style of bolt in the industry right now is cable bolts. What a cable bolt is, it's made to hold roofs almost like a rebar, but it's a lot stronger. If it's put in right, you got almost a 30-ton bolt, and you can put it in a long bolt in a small area without anybody getting hurt. But one thing Genmar will always say, you never spin a cable backwards. This is a sample of a cable bolt that has been spun backwards. A normal cable bolt is rated anywhere from 29 ton to 31 ton. We usually call it a 30-ton bolt. If we spin it backwards and it don't come together, it breaks at 5 ton, just like his sample. Or every roof bolt has its own plate. It is made to be as strong as the bolt itself. One thing you can always tell with a roof plate, if you start to see it deform around the bolt, or if you start to see a loose plate, that means that maybe the bolt is not working as good as it should.
good roof in a coal mine in general would look like, it'd be uniform. It'd look the same from the left to the right. You would be able to see even rock dusting across the roof, and you would also be able to see the bit marks where the miner cut through the rock. A possible indicator of bad roof in a coal mine is in the rock dust, you would actually see a black spot, which means there was a shifting of the roof, a rock slid or fell down a little bit, shifted in some way, shape, or form. That could be an indication that the roof is taking weight. A visual indicator of a rib problem may be what they call bursting or spalling. Spalling is where you find loose coal laying down at the junction of the floor and the rib line. Also, spalling is where the rib actually bursts out. It actually looks like broken pieces. It's loose. It's hanging on the rib. Those are indications that the pillar is actually taking weight. If a miner sees or suspects a problem with the roof, he should call someone else's attention to it, possibly a roof bolter, or if they both can't figure out what's wrong with the roof, they need to contact a mine official. A miner should never go beyond supported roof for multiple reasons. There's nothing there to hold a strata. It's against state and federal regulations. It's just unsafe, and we shouldn't do it. Communication is extremely important in the coal mines. You cannot be in there 24/7. Mine conditions, environment changes almost minute per minute, foot by foot.
Outside Ron, outside Ron.
If you don't communicate that to your cross shifts, they're walking into something they don't know what's going on. They do not know the hazards that may be lying there.
Today's date 6/24, 2011. Area examined is to right. It's time 12 to 1. Face is L3 to R3 plus crosscuts. Violations, conditions none. Dangers none. Last open crosscut, L1 to L2.
If a miner finds a problem during a pre-op, first thing you should do is take the piece of equipment out of service and notify the certified mine official so the problem can be taken care of. No one should ever operate unsafe equipment. Two possible fire hazards you find in a mine are coal accumulations, loose coal, dusty coal laying along the bottom of ribs and on runways. Also, another problem or a fire hazard we can find underground is garbage. Coal accumulations underground can be ignited by multiple sources of heat, either by stuck or sticking rollers, hot bearings, electrical energy through cables and everything else, any type of source of electricity or heat. That's why we have to be very careful with the accumulations of loose coal. Mine garbage is a problem inside the mine. People bring trash into the mine, lunch bags and stuff like that, and don't dispose of them properly. Sometimes they get left laying throughout the mine. It's not only against state and federal regulations, but it's also a fire hazard. If you take it in, take it out with you. The best fire prevention we can have is don't ever let it happen. Pick up your garbage, take care of your section, control your accumulations of oil and also coal. Keep the section clean. With the garbage, if you take it inside, take it out. I mean, it's not a trash can in there. Do the right thing when it's needed to be done. Very fine coal dust, when it becomes in suspension into the mine atmosphere, is extremely explosive. Rock dust is pulverized limestone. It is used in the mine to hold down the coal dust, the fine coal dust, to keep it out of suspension to stop a mine explosion. Rock dust is applied to the roof, the ribs, and the floor. It should have, in proper quantities, it should be white, snow white. If it's salt and pepper or a blackish gray, it's not adequate. You have one tool in your arsenal. It's your eyes. Use them. Look. If you see something you're not sure, ask. check with the people that have more experience than you. There's only one person that ever goes underground that can keep you safe, and it's yourself. You go in as a crew, you go in as a family. You come out as a crew, you want your family coming out with you. We treat each other like brothers, sisters, uncles, aunts, and most of the people who work underground are family. But they're not only immediate family, they're extended family by choice because of who we are and what we do. Coal miners take care of their own. We watch out for one another. We prevent emergencies. We control the situation and make sure everybody comes out with all 10 fingers and all 10 toes every day, day in, day out.